Hello everyone. Today we are going to solve a question from the topic circle. Subtopic is area. This question is from the past paper 4024 summer 2016 mathematics syllabus D. So let's have a look at our question. This is question number 7 and its B part. It states that a baking tray is an open cylinder of radius 15.5 centimeters with a rim. The outer edge of the rim is a circle of radius 16.5 centimeters. Calculate the area of the top surface of the rim. Now we have been given with a tray in cylindrical shape. It has two radii. Capital R represents the radius of the top of the tray along with this rim, whereas small r represents the radius of the bottom of the tray. We have to calculate the area of the top surface of the rim. In other words, we have to calculate the area given by this gray part. This is a separate figure representing the rim, and two radii have been drawn in that. 16.5 is the radius along with the rim, whereas 15.5 centimeters is the radius without the rim. In order to solve this question, in the first step, I have found the area with the rim. So I've used the formula for the area of the circle, which is given by pi r square. Here I am taking capital R, which is the radius along with the rim, and I have put the value 16.5, which is the radius. Now in the second step, I found the area without rim, which is actually the bottom of this tray. So here I have taken small r as radius, and from here, from this figure, I've taken 15.5 as the value of r. Now, in order to calculate the area of the top surface of the rim, we have to subtract area without rim from area with rim. So, we have got this equation. On solving this equation, we get our answer, which is 100.53 square centimeter. Now, we move on to the second part of our question, which states 44 identical circular holes are cut out of the bottom of the baking tray. The area of the bottom that remains is 650 square centimeter. Calculate the radius of each circular hole. I have taken these three figures. This is our old figure which we had been considering before, with two radii, capital R and small r. This is the bottom of the tray, which I have separately drawn from here to here. Now, according to our statement, 44 identical circular holes are cut out of the bottom of the baking tray. So these are 44 blue colored tiny holes that have been cut out from the bottom of the tray. And as a consequence, we have been left with this orange colored area, which is actually 650 centimeters square. What we have to find is the radius of this tiny hole. Now, in order to solve this question, I've taken this equation. Remaining area of the bottom is equal to area of the bottom minus 44 times area of the small hole. Now, to understand this equation, you have to imagine the bottom of the tray. How we have got this equation, remaining area of the bottom, is we have taken out 44 small holes from the bottom of the tray. That is why we have to subtract 44 area of small hole from the area of the bottom of the tray. Now, I have put these values. Remaining area of the bottom is already given, which is 650 centimeters square. So I have put it over here. For area of bottom, I have taken pi r square. Here I have used small r because The radius for the bottom of the tray is represented by small r. Minus 44 times area of the small hole. So, for area of the small hole, I have taken pi r1 square because the radius of the small hole is r1. So, the important thing is that you should be very careful about using radii because you have been dealing with three kind of radii at this time: small r, capital R, and r1. So after putting the values of small r and r1, you have found this kind of equation, and eventually after solving it we get our answer, which is 0.87 centimeter, the radius of this small circular hole. If you have any further question, you may write in the comment box. This was your maths lesson and you were watching Maths with Miss Sumbel.